Welcome back, everyone. In this video lecture, we're going to talk about how memories are stored. So in the last lecture, we talked about how memories are encoded. So now we need to talk about where the memory is stored. How do we retain this information? So again, storage, think about it as a hard drive on a computer or as a file cabinet in an office. It's how we retain the information over time. But how do we know about how that information is stored? So how do we know how storage works? That's a big question. Well, we know that memory is enhanced by elaborative rehearsal, which involves forming associations between new information and other items in memory. So we know that storage has to happen. So there's a few different ideas of how that works. So first we're going to talk about associative networks. And so this is a theory that says that memory can be represented as a network of associated concepts. So an example of that would be a fire truck. So when we talk about a fire truck, we can make a map about things that are associated or related to a fire truck. So we know that a fire truck is a vehicle, so that's like a car or a van. And so a car and van are also related to each other because they're both vehicles. Cool, cool. Well, a fire truck is also red. Well, we know that red makes orange. We also know that blue is another color, so those are all related. So these are all colors. Now, we also know that fire trucks work with fire. Okay, well, fires are red, so that relates back to the color. But fires also give off heat, so heat's related to fire. So you can see how we made this network, or this connected diagram of things that are associated with a fire truck, and then also associated with each other. Now, we could even make another diagram where we could connect red to, say, another circle that's an apple, because apples are red, right? So you can see how things can be connected and can be associated together, even though we wouldn't normally group them together. But then if we have apple and we say connect it to a kiwi, right? Kiwi. Now a kiwi is still a fruit, so it's connected to apple, but you can see how it's further away from fire truck than apple. So kiwi is less associated with a fire truck than, say, an apple. And you can do that by counting these little things. So it's 3 degrees removed, whereas heat is 2 degrees removed from a fire truck. Okay? So that's just an example of an associative network. And so in these networks, then each concept is represented by a node. So a node is the circles here. And then the lines between the concepts represent associations or a relationship. And so the shorter the line, the stronger the relationship. Okay, so heat and fire are more closely related to each other than fire is to fire truck, right? Because you never really have fire without heat, so they have a stronger relationship than, say, a fire truck and a fire. Because sometimes a fire truck goes out, not for a fire, but maybe it's for a parade or to get a kitten out of a tree, right? So you can see why it has a less strong relationship. So how do we use these associative networks? So what you do is you activate or think about one concept will activate another related concept. So by thinking about one concept, what your mind's going to do is it's automatically going to connect it to something else. So again, when I now I'm sure when people are talking to you and say they talk about, maybe if you hear a ring bell, rather than it reminding you of, say, I don't know, bell choir at Christmas time, or the bell ringing between classes in high school, now your brain's going to connect it to a new relationship, a new concept of, say, classical conditioning with Pavlov and the dogs, where they rang the bell and the dog started to salivate, right? So when you learned about the dog salivating to a bell, what your mind automatically did was create an association, or one of those lines between a node, between the bell of Pavlov and the bells that you knew about before. Okay, so every time you learn something new, your brain's going to make a connection or an association between the new information and something you already know about. So we've got this term called priming. So priming is the activation of a concept by another. So again, you've got one concept that you already know, and then you've got other concepts it's connected to. So by activating one concept, what it's going to do is it's going to prime or prepare the concepts it's attached to or associated with to be prepared to be called on. So for example, if we're talking about fire engines, then because we're talking about fire engines, so here's the example, fire engines, then all of these ones that are connected to fire truck or fire engines are going to be primed. They're going to be ready to go in case I ask about them. So if I ask about, so we're talking about fire engines, and then if I say, what color are they? You're going to say red. Because you're more primed or you're prepared to say the color red. Okay, so that's what priming is. Now, of course, sometimes priming can get us in trouble because fire trucks are usually red. But every once in a while, they're yellow. So, if we're just talking about them and I say, oh, what color was the fire truck? And you'll be primed to say red, even if it was actually yellow. But that's just because of this associative networks. Now, of course, you'll probably realize you were wrong and correct yourself, so that's fine. But this is just a great example of how priming works. So again, the exposure to one stimulus influences a response to a subsequent stimulus. And this is without conscious guidance or intention. So we do this automatically. Now, another way to think about how storage works is by thinking about neural networks. And now this also uses the description of nodes being linked together. However, unlike the associative networks, then the nodes are physical. In other words, instead of a node being a concept like a fire truck or a color or a vehicle, then these nodes are talking about specific neurons or specific parts of the brain. So the nodes do not contain a single unit of information. When I'm ask you about visual information, then it's saying that it's going to link to the nodes in the visual cortex, perhaps. Okay, or about neurons that are involved in that task. Okay, so where the associative networks is more of a theoretical connections, the neural networks are physical, real connections. Now, the neural networks is an increasingly popular model, so this is kind of what we use a lot today. This is one that if you guys really like this topic and you're using it for assignment 2, then most of the papers you'll be reading about would talk about neural networks instead of associative networks. So with neural networks, this of course brings up the idea of, well, where is a single concept stored? Because if we're using nodes that are a physical node, so it's a specific neuron or specific part of the brain, then where are these concepts stored? And so within that neural network, are there patterns or sets of nodes that activate together? And we've actually found that, yes, that depending on what you're talking about or listening to, different parts of the brain will activate together in response to specific types of stimuli. So we will also call this sometimes the parallel distributed processing model. In other words, we're saying that the same piece of information will be stored and processed in different parts of the brain as kind of a backup. And so when you recall or need to use that specific piece of information, all parts of the brain that hold that information will fire together. So that's it for storage. So again, remember, storage is how we maintain and keep the information that we encoded, and that there's two main models, the association networks and the neural networks.